Okay, common factoring. We have a quadratic here. Now this is in the vertex form that we've been used to seeing. This is actually considered standard form, but we'll get into that a little later. Common factoring is when we look at each value, and in this case there are two terms here. Remember, an addition or subtraction sign separates our terms. We look at each term and we try to find values that are divisible by both of them. Okay? So the first thing we're going to do is we're going to focus on the coefficients, which are the numbers in front of the variable. I have a 2 and a 6. Okay? Now if I'm not sure what to do, I can do something like this, 6 and 2, if you guys remember doing this. And what we're going to be looking for is called the GCF, the greatest common factor, between those two values. So what I would do is write out my factors of 6 and 2. Factors of 6 are 1, 2, 3, and 6. And the factors of 2 are 1 and 2. I then look for a common factor. 1, obviously, comes out of everything, and 2. 2 ends up being our GCF. Okay. So what I'm going to be doing is I'm going to be dividing both of these values by 2. Now, some of you guys might get confused here. We're not dividing the other side of the equation by 2. You guys remember your balancing of equations. Whenever you do one side, you must do the other. In this case, we're removing a value. Okay? So we're removing 2. We're also going to be looking at the variable. And we can do the same things with the variables here. We can find a greatest common factor. We have an x squared and an x. Okay? And really what I'm going to do is I'm just going to write out, because our variables are usually just written to an exponent, I'm going to write out the number of variables within that value. So for instance, x squared consists of 2x values, and x only consists of 1. Okay? So what we do is we take out as many from each as possible. So because there's only 1 on the bottom, I can only take 1 out of each of these. In other words, an x to the power of 1. So we're going to be dividing, again, each of these values by just x to the power of 1. How many of you guys might have been able to see that right off the bat? 2 and 6?
I can't see now.
Yeah. So, sorry, like we were saying, we're going to take 2x out of each of these values. When we do that, I want you guys to recognize 2 divided by 2 creates a 1 or cancels out, as you guys see it. And x squared divided by x just leaves us with a value of x on top. So the value that we took out, which is our 2x, comes outside of the brackets. And we'll still have 2 terms in the brackets because we started with 2 terms. Okay? And what those 2 terms will be are the values after we've divided them by 2x. So like we said, 2x squared divided by 2x just leaves us a value of x. And 6x divided by 2x will leave us with what? 3. And recall that there's a negative sign in front of it, so consider it a negative when you're doing the division. Comes x minus 3. And that's our common factor. We took 2x outside, and we have x minus 3 on the inside. So a lot of steps for a very simple process. We'll go into one a little more difficult, and we'll go through it a bit quicker this time. Because we divided each term by 2x, so that 2x goes to the outside of the brackets. Okay? It just stays on the outside. This is the opposite of what we were doing with distribution. Remember with distribution, what we were doing was bringing this in. And that's how you can check. If you need to check this, multiply this value back in, and you should get what you originally started off with. We're just doing the opposite of that today. Okay? So, let's say another value here, f at x is equal to negative 3x squared plus 27x minus 9. Okay? Very first thing I want to do is take a common factor out. So this time I have 3 terms, right? We have 1, 2, 3. We have an addition and a subtraction sign separating everything. So I look at the coefficients first. What do we think will be a good coefficient here? 3. Okay. Now, just as a heads up, in the future when we go through this, we usually want our first value to end up as a positive value. So if I have a negative 3 or a negative value in the front, I probably want to divide by a negative value. Okay? So we're going to divide each of these terms by negative 3. And is there A variable I can divide each of these by. I can't divide it by x because there's nothing at the end here. Okay? So really all I can do is take out our negative 3. That's the only common factor I really have here. So the negative 3 comes to the outside of the brackets. And the 3 terms that will be left inside are what the 3 terms are after we divided them by 3. So what's negative 3x divided by negative 3? X squared. Positive 27x divided by negative 3. And negative 9 divided by negative 3? Plus 3. And that's it. We have our negative 3 on the outside, and we have x squared minus 9, x plus 3.
I'm ready.
Okay, common factoring our third example here. This is very different looking from what we had. Okay? In fact, really, I got 2 brackets here. I'm not quite sure what to do. What I'm going to notice is that each of these brackets are what? They're the same. Okay? So there's 2 ways we can go about this. You can notice that they are the same. It's okay, I'll fix it. Okay, so like we said, our brackets are the same here. So there's 2 ways we can go about solving this. I'm going to split this page. Okay? We're going to do one version on the left, and one version on the right. So the version on the left, we're just going to keep it as is. And the version on the right, we're going to use a let statement. Now, the version on the right here, 3x, sorry, that's the left, 3x multiplied by x plus 1, subtract 2 times x plus 1. And the version on the right, exact same idea, same question. Now, what we're going to do with the let statement in this version is we're going to simplify this so it's a little easier for us to see. So what I'm going to say is a let x plus 1 equal the letter a. Okay? And then when I go to rewrite this, I'm going to have 3x times a minus 2 times a. And we're going to do it this way first. Okay? Do you guys see a common... First of all, what's the common coefficient between 3 and 2?
1.
It's just 1. Do I really need to divide by 1?
No.
No, it's not going to make any difference. Is there an x in both of these? Can't do that. What can I divide each of them by? I can divide each of these by the value a for a common factor. Okay? So we're going to take a to the outside. Okay? What will I be left with inside my brackets here? 3x minus 2. But the original question never had an a in it, so I do have to substitute it back out. What do I have to substitute back in for a? X plus 1. So our final answer here is x plus 1 times 3x minus 2. That's what the let statement. That's it. That's your final answer there. Now, let's say we did it without the let statement. What you would have to do is A, recognize that there's an x plus 1 in both of these. And what we'll be doing here is dividing each term by x plus 1. Okay? Which seems like a little more difficult to look at. But it's still the same idea. Because we're dividing each by x plus 1 comes to the outside. And in our new set of brackets, our x plus 1 and x plus 1 cancel out. So what is my first term?
3x minus
And what's the second term? If you notice, the answers are identical. Okay? Both of these are the exact same thing, though we used one in the let statement with a few more steps, and the other one we were able to recognize right away. Whichever you find more comfortable, I suggest you use when going through. Our last example here, they've given us the area of this triangle. Okay? We need to find the base of this. So, the area of a triangle is what? Anyone know what the formula is? Base. Yes, base times height. And it's technically divided by 2. Okay? Because it is technically divided by 2. This is the area. So this question is a little more complex. Okay? We know that the base times height is not going to be exactly this. What's going to be different about it? For instance, we don't know what the base is. The base is an unknown. Okay? If you want, you can call it y in this case since we don't have a y. We know that the height is 3. Okay? So 3x times our y value, which we got to figure out, is going to give us not this, though. Because that's the area of a triangle. It's going to be this with what? Think of it like this. Base times height divided by 2 will be equal to 12x squared plus 48x. Okay? Times 48x. This 2 value is going to need to actually be put into this in order to figure out what our base is. So if I bring this 2 over, I need to multiply both these values by 2. Okay? So we're left with 3x, y, that's our unknown, is equal to 12 times 2 will give us 24x squared. 2 times 48 will give us 96x. Okay? We're still looking for our y value, so I want to get y by itself. I'm going to divide every side of the equation by 3x. So this is very common to, or very close to common factoring. We're dividing both of these by a coefficient and a variable. So our base, which we've called y here, will be equal to what? What's 24 divided by 3?
6, 9, 8.
Yep. X squared divided by x? 96 divided by 3? 32. X, okay? And this is our base. So the area of this one is a little more complex. We had to think the area of a triangle before we could get started. It's still the same idea. We're dividing values by a common factor, you could say.